Hi everyone, welcome to today's webinar. Today, our webinar is part of the CDE Open Day 2024, and this webinar will be on how sustainability and ISE come together for the bachelor degree of engineering in ISE. So my name is Tian, and I'm a lecturer at the Industrial and Systems Engineering and Management Department. And today I'll be giving you a little overview on how sustainability and ISE have come together and how we have tried to incorporate it into our ISE curriculum. So this is the outline of my presentation today. I'll give you an introduction to the ISE Bachelor of Engineering major and an overview on sustainability and the green economy in Singapore. And then I'll tell you how ISE is relevant to some of the sustainability problems that we face today and how we have tried to incorporate it into the curriculum in our Bachelor of Engineering degree. And then I'll be presenting two student projects, one a systems design project, which is a collaboration with the industry that all students will have to do, as well as a final year project, which is a research project. So we'll have a final year student come to present his final year project as well. So first, to talk about the Bachelor of Engineering in Industrial and Systems Engineering, there are 4 skill sets that you will be learning in the Bachelor of Engineering. The first will be data analytics and decision making, and you will learn skills like operations research, machine learning, decision analysis, mathematics, probability, and statistics. And to build on these quantitative skill sets, we will then add on computational and modeling skills, including things like Python, Microsoft Excel VBA, as well as various software related to the different quantitative skill sets that you would have learned under the data analytics and decision-making skill sets. And following that, you will build upon it with project and operations management, and this would include learning how to manage projects, finance, cost analysis, and quality. And finally, the last skill set that you will learn is systems engineering and analysis. This gives you the systems thinking and dynamics to look at problems from a macro level, supply chain systems, and other systems including manufacturing and service systems. So understanding things from a systems perspective. And when we take all of these 4 skill sets together, they are able to be applied to various real-world problems. And some of these areas of specialization or real-world problems that we offer here are supply chain analytics, analytics and decision intelligence, and sustainability analytics. So today's webinar will be focusing on the area of specialization of sustainability analytics. More about the Bachelor of Engineering. You will be taking some common courses in the College of Design and Engineering, and these will build the foundation and skill sets required for common core courses and an understanding of engineering. And then you will have to take some ISE courses, and you will be given the option to take some technical electives, as well as to choose a specialization. So these specializations and ISE electives allow you to go deeper into the area that you're interested in and to apply some of the foundational skills that you have learned in the common core courses. You will also be able to take unrestricted electives. These unrestricted electives allow you to explore new areas, for instance, language, humanities, and sciences, something outside the College of Design and Engineering. You will be doing an industrial attachment as well. This industrial attachment will allow you to apply the skills that you learn in the common courses and the ISE courses, and you will be able to learn to collaborate with the industry and to understand how these skill sets can be applied to practical and more complex problems beyond the classroom, beyond the examinations, to understand how these skill sets are applied in real-world systems. So the next thing that you will do is a systems design project, usually done in the 3rd or the 4th year. And this systems design project is a collaboration with the industry, where the industry provides a real world problem and a group of students. So you'll work in a group of students will work on this systems design project. You will go down to the site, understand the problem, talk to the industry, and you will have an industry supervisor. So throughout this 1 year long or 2 semester long system design project, you will learn how to apply certain skill sets that you have learned in the common courses, in the ISE courses and electives to a real world problem and try to address this real world problem with these skill sets. And usually these real world problems have not had solutions yet. And so our students are trying to come up with innovative solutions to these problems in the industry. And finally, research and innovation. You will be able to take a final year project or an independent study course, ISC. So final year project is 1 year long or 2 semester long, and ISC is 1 semester long, and it focuses more on research problems instead of industry problems. So you'll look at some of the research problems and then again apply the skill sets that you have learned, the 4 different skill sets, the skill sets that you have learned in the common courses and ISE courses, and try to address these research problems. So this is a general overview of the Bachelor of Engineering. And we have a new area of specialization that has just started last year, and it is the specialization in sustainability analytics. So then the question will be, what is sustainability analytics and why are we offering this specialization under the Bachelor of Engineering ISE? So I'd like to bring your attention to this article in Bloomberg. This article mentions that the real climate job of the future is a carbon accountant. So it raises many questions. In fact, this article was published last year in 2023. Firstly, what is a climate job of the future? And what is a carbon accountant? So a carbon accountant is somebody who tries to estimate emissions, understand various trends, report greenhouse gas emissions, and tries to address the issue of climate change and the energy or the green transition. And to say that this is the real climate job of the future suggests that there is an interest in building up capabilities to be a carbon accountant. And in fact, the ISE degree actually has many elements that help to build skill sets required for a carbon accountant. But the first question really is, why a carbon accountant as the real climate job of the future? So I would like to bring your attention to a couple of recent requirements for reporting. So the first would be that since 2023, listed companies have to do sustainability reporting to the Singapore Stock Exchange. And so companies have already started to try to do this type of sustainability reporting to the SGX. And more recently, it has also been announced that there will be mandatory climate reporting via the Companies Act in Singapore starting in 2027 for non-listed companies that meet certain criteria for being sufficiently large. So we see that in Singapore, there are increasing requirements for sustainability reporting, which will require companies to report on their greenhouse gas emissions on top of other sustainability-related metrics. And this is where the job of a carbon accountant will come in, that you will need to be able to understand energy systems, engineering systems, and be able to estimate emissions and report these emissions. And on top of that, there has been an exponential increase in corporate net zero emission targets since 2020 globally. So I'm not sure how many of you have heard of the term net zero, and I'll talk more about that later. But this transition and exponential increase in corporate net zero emission targets has pushed many countries and corporations to not only set these targets, but also require a transition plan to meet these targets. And sustainability departments have sprouted out. People are interested in sustainability specialists or sustainability analyst roles, and these roles are actually both for reporting as well as for transition planning. And the ISE skill set is able to help to address some of these real world problems in terms of the energy and green transition, as well as reporting. So I'll talk more about that in detail later. And first, the question is, what is net zero? Net zero, if you have heard of the word being thrown around in the media, refers to getting to net zero greenhouse gas emissions. And why do we need to get to net zero greenhouse gas emissions? We have seen here from the chart shown here that there is actually an increase in the average temperature globally. And this is what is known as anthropogenic climate change or global warming, meaning that the average temperature globally has increased due to human activity that increased the concentration of greenhouse gases in the atmosphere that traps heat. And so this is a problem that has led to multiple climate impacts, and it is a problem internationally that needs to be addressed. So the question is, what can we do? And one of the things that can be done is to try to reduce greenhouse gas emissions, to try to reduce the increasing trend of global warming or global temperature increase. And this has encouraged internationally corporations and countries to set net zero greenhouse gas emission targets. And this is how the idea of net zero came about. So to put it in another perspective, here now we have the y-axis being the CO2 or greenhouse gas emissions in CO2 equivalent. And we see that we are currently here on the black trajectory. And if we continue with the policies that are currently implemented, we are likely to move along here, which is the red line, in terms of the total greenhouse gas emissions emitted over the years from 2000 all the way to 2100, which is the end of the decade. And we see that net zero refers to this blue line here, which is to try to limit warming to 1.5 degrees Celsius in line with the Global Paris Climate Agreement. And you can see that from the red line to the blue line is very, very ambitious. So this is a very ambitious target of reducing greenhouse gases to net zero, and it requires a radical transformation of the energy and energy system as well as the economy. And that is what we call the green transition and the green economy. And how do we get there is the next question. So how do we transition to net zero? It starts off with measuring. So we will need to be able to measure, estimate greenhouse gas emissions and report these emissions. And then when we have emissions every year, we'll be able to do a trend analysis to try to understand the trends and also understand some of the driving factors. After we have understand the trends and the driving factors, then we can do scenario analysis, forecasting, and an understanding or building of transition pathways. And when we have these scenarios, we'll be able to do target setting and progress tracking through various different types of quantitative tools. And finally, after we've set our targets, then we will be able to plan and try to understand carbon-intensive and energy-intensive systems and market mechanisms to see how our corporation, country, or the entire world can move towards a decarbonized energy system and a decarbonized economy. And then implement data-driven policy solutions and emission reduction measures. So we see in this entire process flow all the way from measure to do, plan and do, that many of the concepts learned in ISE are actually applicable. We see scenario analysis, forecasting, quantitative tool sets, computational, etc. are all within this particular process. And so now I'd like to summarize how everything comes together for the Bachelor of Engineering in ISE. So first, we start with engineering knowledge. So the common core modules will provide certain understanding of engineering systems that is required to understand various types of systems that are energy or carbon intensive, for instance, in power plants, etc., in manufacturing. Also, it allows for an understanding of climate mitigation solutions, which are technological solutions that can be implemented to try to address climate change. So this is how the general College of Design and Engineering concepts come into play. And then for ISE, very specifically, there's the systems perspective. So here we can understand energy and economic systems from systems thinking perspective, and also try to dissect and understand a problem from a macro level using the lens of systems thinking. And then now to the 4 skill sets that you will learn in the Bachelor of Engineering in ISE. We have data analytics and decision making. Here you will learn various skill sets that are shown here, including forecasting, scenario analysis, optimization, uncertainty and risk analysis, and these are required from the green transition. For project and operations management, you will learn cost analysis, as well as financing and carbon pricing and carbon markets. Systems engineering provides a systems thinking perspective, as well as certain tool sets like life cycle assessment, which is a type of carbon footprinting accounting, and an understanding of industrial systems, as well as energy productivity. And finally, computational and modeling skills will provide the skill sets required to implement certain quantitative tools, as well as learning of software, dashboarding, and database development, which is very important throughout the entire process, all the way from estimating emissions to the transition planning stage. So we see that actually many of the ISE concepts equip students very well with skill sets that are required for the green economy. And therefore, we have launched the Bachelor of Engineering Area of Specialization in Sustainability Analytics. And you can find this information on the website. So to receive the specialization, you will need to fulfill the requirements of the primary major and pass at least 20 units from the following list of courses in the table below. So there are two baskets of electives, one focusing on analytics and one focusing on sustainability. And you can also do a final year project, which is the Bachelor of Engineering dissertation, which will give you 8 units. And what are the career opportunities for ISE graduates? There are actually many opportunities. The opportunities in government agencies, where many agencies are in the process of trying to plan for the transition to get Singapore to net zero, the understanding of energy systems and decarbonization. This also occurs in various research institutes. We have energy companies, including electricity providers, renewable energy, and fossil fuel companies looking at pricing, looking at decarbonization and transition planning. There have also been many sustainability departments increasingly being set up in companies in various industries to address, firstly, the reporting requirements, and secondly, the net zero transition. So these sustainability departments in various companies include financial institutions, manufacturing, and real estate. There are also jobs available in consulting that requires knowledge of sustainability and accounting in specific industries, including buildings, shipping, and aviation. Increasingly, data providers of certain data, for instance, data providers that used to provide financial information, are also looking to provide information related to sustainability, greenhouse gas emissions, indicators and metrics, and estimation tools for emissions. So these data providers are also looking for people who are able to understand the data, who are able to analyze the data, and provide the software as well as the quantitative knowledge to try to bring everything together. And increasingly, there are individual companies that are being set up specifically for the purposes of energy and sustainability consulting, in terms of reporting, in terms of climate accounting, in terms of climate auditing, and sustainability reporting. We also see companies sprouting out for accreditation and certification of green products and green buildings, ESG rating companies, companies that rate other companies, as well as carbon markets and exchanges. And some of these skill sets that you will learn in ISE will prepare you for these jobs in the green economy. And with that, I would like to present 2 student projects in sustainability to give you an idea of how the courses come together with the projects to try to allow students to look at sustainability or problems in sustainability through the lens of ISE and through the skill sets and application of these skill sets. So I'll be presenting the systems design project, which is a group project in collaboration with an industry partner. And then one of our final year student, Mr. Cai Guiqing, will be presenting his final year project, which is a research-based project looking at sustainability and decarbonization. So first, the systems design project. This project was actually done by a team last year. It completed last year, and it looked at a real world problem faced by a financial institution in the estimation of emissions. So this project was actually provided by Standard Chartered Bank, and they like our student to look at how we can better estimate emissions occurring from a category known as Scope 3 Category 15. So Scope 3 Category 15 emissions are actually financed emissions or emissions occurring from the company that a bank finances. So it is actually difficult to try to estimate these emissions because these emissions do not occur due to the bank's operations itself, but due to the financing that the bank provides. So we see here the problem description. You can find the entire poster on the website shown here, and all past systems design projects are also shown at the website here. So if you are interested to know more about the systems design projects that have been offered in the past, so that you can have a feel of what are the projects that you could possibly do or the companies that you could possibly collaborate with, you can go to the link shown here. So back to this systems design project. So this systems design project, together with Standard Chartered Bank, what the students did is to try to look at the problem first. So Standard Chartered Bank has a methodology for estimating emissions, and the data coverage is 61% from a database, S&P True Cost, and then the remaining 39% are estimated based on regression with a 15% error rate. And the model is a revenue-based model, meaning that it only takes into account financial features. So the objectives of the student project was to enhance the data coverage, try to enhance the data coverage, explore more emission estimation methods, and try to improve the estimation model by incorporating both financial and non-financial features. So this is what the students have developed at the end of the project. They went through the data collection phase, statistical check, and tried to enhance the model performance. They then look at the results, compared the different models, the original model, the new model, as well as the different models. So they tried a variety of models, and then finally gave their recommendations. So what they did is to try to employ a two-level approach to the regression methodology. And instead of just the financial features shown in blue here, students also try to include non-financial features in their model. So these features include renewable energy consumption, non-renewable energy consumption, as well as categorical features such as daily oil production by region and subsector. So this increased the ability of the model to try to estimate the emissions more accurately for the sectors that it finances in oil and gas, compared to if we are to only use the financial related features shown in blue. And so the students actually improved on the model, and it's actually quite an innovative improvement to the model in the sense that it has not been done very extensively or widely in the literature in terms of trying to incorporate energy-related features, non-financial features within such a model. So this is what you can expect in a systems design project that will span 1 year or 2 semesters. You will work with the industry, understand the industry problem, and then try to approach this problem using some of the skill sets learned, and then try to come up with a solution that is innovative, that addresses some of the problems that are faced by the industry today. So next up, Mr. Cai Guiqing will be presenting his final year project. This is a research project focusing on maritime decarbonization, and his project title is Green Fuel Adoption in International Shipping, and he applied system dynamics to try to look at the challenges in green fuel adoption. His supervisor is Associate Professor Chai Ka-hin. So what I'll do now is to hand over my time to Guiqing so that he can give you a little insight into his final year project, and then after his presentation, we'll do a Q&A where you can ask questions about the degree program, STP, FYP, and any other questions you may have about the Bachelor of Engineering in ISE. Okay, so now I will hand my time over to Guiqing.
Okay, thank you, Dr. Go. Yeah, so let me share my screen. Hi, can everybody see the screen?
Yep, I can see your screen.
Okay, yeah, so really happy to be here today to be able to share on my FYP and how ISE can actually help us to understand more about sustainability and how some of the concepts learned can actually be applied in this field, and what are some of the experiences and insights that I have gained through my final year in ISE as a graduating student doing this FYP, and how this FYP has potentially helped me maybe say in securing a job. So giving you a bit of like insights of how ISE actually works. Yeah, so I'll begin. Yeah, so my project title is actually named System Dynamic Approach to Green Fuel Adoption in International Shipping. And before I kickstart my presentation, just want to let everyone know like why do we actually learn about systems thinking, because in ISE we do learn a lot of system thinking. So basically everything that is surrounding us is actually a system. Our body itself is a system. So by studying the systems, we actually can help to solve a lot of things that is happening around us. And some of the system problem can be, some of the traffic congestion, how effective is some of the restriction policy, the Singapore car plate bidding lottery, which one is better. So it's this kind of like situations that we sometimes have to dive in and try to look for solution or look for some of the bottlenecks. And in a systems thinking, we often have to consider many different stakeholders with different level of perspective in this case. So as engineer, we have to design a good system, and sometimes we also have to look out for some of the problems in the existing systems. So um, there are a lot of ways to analyze a system. We will be taught different models in ISE, like what Dr. Low mentioned just now, be it operational research or be it simulation. But today, the one that I'm going to share is on system dynamic. It's also one of the modules that you might take in your undergraduate years in ISE. And during these modules, I was actually being taught on how to apply system dynamic models, create graph and run the modeling to solve for the systems problem. So just give you a brief description of like what a simple system problem is. For example, let's say look at a fish population model. So the fish population actually, they have a hatch rate, they have a death rate, and then there's a carrying capacity. So basically there are different sorts of conditions and also different variables, and these actually forms a system, as you can see from the plus and minus. So it's actually like a positive or negative feedback to the entire system. So this is like a simple system that we might observe in our daily life. So now I'll give you a bit of insight on what this project is actually about. So before I chose my final year project, the department actually gave us a list of projects for us to choose. And this project, particularly green shipping, caught my attention because I think this is quite interesting. And as you all know, decarbonization has been the hot topic in the recent years, especially sustainability. So I took up this project with the aim to learn more about sustainability and also how hoping that this project can actually help me in maybe securing a job or an internship. So uh, I'll now talk about the research motivation behind this project. So this project is done because there's a rising sea shipping over the last decades. So international trade volume has rocketed since 1950, and sea shipping accounts for more than 80% of the world trade. And of course, everyone knows that this definitely lead to a greater emission of greenhouse gases. At the same time, there's a lot of green transition efforts going on by a lot of like the different government agency and also private sectors. So there is really an urgent need for decarbonization propelled by IMO's goal. So um, there are a lot of efforts, but the progression itself might not be fast. So there's a lot of bottlenecks. So what we want to do in this project is to potentially identify what are some of the bottlenecks so that solutions can be provided. So the research objective is that by leveraging on this system thinking approach, which was the system dynamic approach that I mentioned previously, this was actually a module that was taught back in year 2 of my ISE undergraduate years. And it is a less conventional approach in shipping. So I was not confident that it will actually help to solve the problem initially. But after doing a lot of research and also consulting with my professor, Prof. Chai, we actually think that it might be a possible solution to what we are facing right now. Although it might not be a very conventional approach in this shipping industry, we hope that this system dynamic approaches can help us understand and see a bit things that are different from what the current research is about. So we want to understand the relationship between the stakeholders. We want to explore the possibility of this system dynamic in maritime shipping. And through these approaches, we want to understand the current gaps and identify the bottlenecks by doing some of the modeling. So the methodology that I implemented in this project was firstly the stakeholders and value chain mapping, and also system dynamic approach, which includes causal loop diagram and store and flow modeling. Lastly, to validate with a green corridor case. So of course, throughout this project, I have to do a lot on the literature review to actually, research on what are some of the current methodologies that the green shipping industries are using, and then compare it with system dynamic. So why system dynamic in this case? Because it's ideal for non-linear and feedback-rich systems, and it can be used to model complex network of stakeholders. And then it also gives you dynamic interactions and feedback loop while accounting for some of the possible delays. As we all know, when you implement a policies, some of the effect might not come immediately. So it also has been a tool for transportation planning in land transport and evaluating development strategies. So as it reflected its usefulness in land transport, me and my professor, we want to bring it into the maritime shipping and explore the potential solutions there. So this is like a simple form of system dynamic. And there are a lot of studies going on for system dynamic to be used in transportation in general. So for international shipping wise, there's a lot of things going on right now. Ocean shipping handles 90% of the global trades, contribute to a shocking 3% of the greenhouse gases. And then throughout this project, I also research on the IMO's regulatory measures and actions. And you also have to examine what are some of the industry's movement in this case, and what are some of the innovation and commitment by both the public and the private sectors. And also have to research on the alternative fuels and what are some of the gaps and shortcomings during these projects. And then there's a lot of stakeholders in this project related. So I was happy to be given the opportunity to attend some of the conferences and also some of the meetings that my professor brought me to, where I managed to talk to some of the different stakeholders, be it the agencies officers, and also some of the private firms that is actually handling some of the shipping industries in Singapore. So actually it gave me a lot of exposure and understanding to sustainability and also the maritime shipping industry. And this actually better prepared me to do the stakeholder mappings, where I actually map out all the value chains. In this case, firstly is the international supply chain, and also the marine fuel value chain, and also the shipbuilding value chain. And from all this, as I've mentioned previously, since I was able to go to the conferences and some of the meetings, I actually managed to have a better understanding, which then helped me construct this causal loop diagram that involve a lot of the different stakeholders. And this is really important for me to move on with this project by first establishing the clear connections between the different parties. So I will go through briefly on some of the modeling that I eventually did. So firstly is about the store and flow modeling, where I have to construct the causal loop. And these are the submodels that I developed. So basically in this system dynamic, you will learn during your lab lessons on how to construct firstly things like a causal loop, and then construct a model that actually let you fit in the numbers to run the models to try to analyze the results. So here are some of the models. I think I'll just go through it quickly and go to the final models. So these are some of the models that I constructed. So after constructing the models, I was actually given some of the data that the school provided me with to validate the models and to see what are some of the findings that we can actually eventually come to. So basically, we can see that there's an initial positive response to green fuel. However, the green fuel availability actually drops, and this might be due to the technology limitation in this case. And for example, you also um, wave in the policies that we have, such as short-term incentive and how short-term incentive decreases the long-term effort, and how this eventually impact the entire greenfield and technology development. So the green transition actually fluctuates depending on the number of the incentives that were given in these cases. And eventually, I managed to construct more complex model by merging these submodels together and providing some of the other variables. And the overall model was then constructed and validated with some of the data. And we actually found out that yes, there's infrastructure and technology bottlenecks at the moment, and that limits how much greenfield is being produced. And then another thing is that some of the short-term gains that uh, the maritime industry is focusing right now actually deteriorates some of the efforts that we might have in the long-term vision. So, um, so the conclusion is that greenfield production capacity is limited because of the technology, and then we have to balance some of the short-term goals and long-term ambitions instead of just focusing on the short-term goals to meet the regulatory, and also in greenfield and also sustainability, long-term persistency is definitely required by both the public and the private sectors. Yes, so although that this is just an undergraduate project, but I managed to explore some of the potential solutions that we might take and implement. And it shows that some of the skill set that we learn throughout our undergraduate years actually can also be helpful in solving real life problems such as sustainability. And it's a project that as long as you put in the effort, you do the research, and you consult on your supervisor, you can actually come to a very fruitful conclusion. Yeah, that's all for my presentation. Thank you, Dr. Goh.
Thanks, Gui Ting, for the very insightful presentation. So as everyone can see, for the final year project, you will be working on a research project, and the research project also gives you opportunities to interact with the industry, like what Gui Ting managed to do, to interact with certain stakeholders in the shipping industry and work on a really pertinent and current problem, which is on a decarbonization of international shipping. So this is actually an ongoing research project in the Industrial and Systems Engineering department, where we have different researchers working on it, and final year project students are also welcome to work on some of these projects in international shipping or in any other area in sustainability. So with that, I would like to move on to the Q&A section. So if you have any questions regarding the Bachelor of Engineering degree, regarding the FYP, the SDP, or the internship, or any other question, please post it in the chat box so that we can address your questions. You can also post it in the Q&A box or the chat box if you have any questions. So I'll give you everyone a little while to post any questions that you may have. Okay, so the first question that we have is, which specialization, aside from sustainability, is the most popular right now? I am not very sure which one is the most popular actually. I'll need to check with the department, but there are two other specializations. One is supply chain, and the other is analytics and data and decision intelligence. So regarding the specialization, in fact, sustainability analytics is a new specialization. So previously there were only two. So let me answer the next question. The next question is, what do I need to have before I join ISE? Is math heavily intensive? So there is probability and statistics, and you will also be learning engineering statistics at a level 3000 level 3000. So I would say that it would require a certain amount of mathematics. But maybe I will ask Gui Ting, who is currently a student, a graduating student, to maybe help out and see if you have any views on whether math is heavily required in the ISE curriculum.
Yeah, sure. So I would say that math is definitely required, but whether or not it's heavy is really depends on what specialization you are going into and also some of the modules that you take. But I do feel like the professors and the staff here actually give you very good guidance because I do have friends that came in with slightly, I would say, weaker math foundations, but we all managed to get through the modules together because the prof, the TAs are really there to help you. So I don't think you have to worry about that as long as you put in the efforts. The math part should be okay. Yeah.
Thanks, Gui Qing. Yeah, the other thing is that in university there will be tutorials, and then when you go for the tutorials, it is a way to try to interact with the teaching assistant and clarify any doubts that you have. So this will also help in terms of answering any questions if you feel that you need help in math um foundation, and you can also book a slot with your lecturer or your professor, and then they can also help you out if you really face difficulties in tackling some of the probability and statistics courses. Okay, the next question is, what's the employment rate for ISE graduates compared to other majors? You mean in the College of Design and Engineering? So you can look at the graduate employment survey. I would say that the employment rate should be above average, and also the average salary, if you look at the graduate employment survey, I believe that it's actually above the average for in general for the College of Design and Engineering. Yeah, but you can take a look at the graduate employment survey. The next question is for sustainability analytics specialization, do you need to do FYP? Is there an option not to do FYP? So yes, there is an option not to do FYP. You can choose to do an independent study course, which is a shorter version of FYP. It is only 1 semester, and it gives you an opportunity to try out research, but then not doing a full-fledged final year project that is 1 entire year long. I understand that moving forward, you can also choose just to do the courses itself. So if you see the requirements, you will need to fulfill 20 units. So you can actually take 5 courses in the 2 baskets, and you'll still be able to get the sustainability analytics specialization without doing the FYP. Okay, so another question is there any criteria to get into a specific specialization? Is there a quota? There's no quota on the specialization. As long as you fulfill the requirements for the specialization, you will be able to get the specialization. And you can choose which specialization you want to do. Yes, so you can choose either of the 3 specializations. You just need to be aware of the criteria required. So for instance, you need to take modules from technical electives from basket A or basket B, or certain number of technical electives. So different specializations have different requirements for the technical electives that are required. And then another question is okay, does ISE have a lot of physics in the curriculum? I think that it does not have a lot of physics from my perspective, but then I will ask Gui Ting again to see if he can help to answer this question about whether there's a lot of physics. Sorry about it, Gui Ting. Yeah,
Okay,
thanks.
no worries, no worries. Yeah. So, okay, to be really honest, if you don't like physics, then that's a good thing because from what I remember so far, we only had one intro physics module, which is similar to your JC H2 physics or something. So apart from that modules, I don't think physics is really needed. Yeah. So I don't think that should be a worry.
Okay, thanks, Gui-Ting. Yeah, I believe that it is one of the engineering course majors that have a less requirement for physics in the curriculum. The next question is, when do we choose our specialization? So there is no time to choose a specialization, but some students plan ahead and start to take the technical electives in year 2 is possible. But if you only choose to take the technical electives in year 4, then you may not be able to get your specialization because it might be too late. So it's better to plan early. So there are people who try to take the technical electives even in year 2. Another question is, can you do all 3 specializations? I would think that it would be very difficult to do all 3 specializations because of the different technical electives that are required. And in fact, you only need 2 technical electives to graduate with the bachelor degree. So I'm not sure whether you will be able to take so many technical electives to be able to graduate with 3 specializations. But you can check with the department whether they are able to give you that. But another option that I will suggest for people who are looking at having these specializations is that you can choose to have one specialization in ISE, and then you can have a minor or something else to try to increase the breadth of your degree, and you do not necessarily need to try to get all 3 specializations that are being offered. So there is actually flexibility in the degree to try to get a minor in something else, or to get a second major in something else that is within the college or outside the college. Another question is, what is the current Singapore and international market demand for fresh graduates with sustainability background? From my perspective, there is a huge demand for people with sustainability background currently. You can do a search on LinkedIn or Google, and you will see that there are new jobs roles available that were probably not available 3 years ago, called sustainability specialists, sustainability analysts, carbon accountants, these types of roles. And in fact, there are also sustainability departments that are beginning to be started in certain industries and companies that previously didn't have a sustainability department. And there are companies that are being set up specifically for consulting in sustainability, as well as in carbon markets and carbon exchanges. So in Singapore, we have a few carbon exchanges running as well, and there is a demand for people to work in this particular industry. Okay, the next question. What's some transition currently happening in the supply chain industry that we might apply sustainability on? So I think that one of the things transition in the supply chain industry was actually shown by Gui-Ting's FYP. So this transition is really in the logistics and supply chain industry in terms of shipping. And we see that there is an increasing push for decarbonization, which would mean that there will be a need to move towards green fuels for the supply chain industry. And this is not only focused just on maritime, it's also focused on last mile road transportation and air freight transportation. And so the supply chain industry is being pressurized to come up with decarbonization transition plans, and also to be able to track these decarbonization transition plans in terms of the carbon footprinting of the goods that you receive. So, you know, when you order from Shopee or you order from Lazada, and then you want to know what is the carbon footprint of this particular good that has been transported to me. And so these are some of the things where the supply chain industry is actually overlapping with sustainability. And in fact, there are some internships available in this area as well that I have seen on the internship portal. So you might be interested in some of these internships. And there could also be final year projects or ISC and independent study courses in this area. Okay. From the ISE page, it says that with the right modules, one can become a data scientist or a data engineer. What are the chances in getting into the industry? as compared to data science and analytics degree. So I'm working from the department, and I would say that we have students who are working in areas of data scientists and data engineer. I wouldn't be able to tell you what are the chances of getting into the industry, but we do have students working in this in terms of all the three pillars of the future economy that the government has mapped out in terms of the green economy and the digital economy, as well as the care economy in terms of healthcare. So we do have students working as data scientists in all these areas. Another question that I have is, what is the difference between systems engineering and engineering science? So systems engineering, as I showed earlier, covers the 4 areas. So we have data analytics, computation, project management, and systems engineering. Whereas engineering science focuses more on the science. You can look at the specializations; they are completely different. They have things focusing on nanotechnology, etc. So they really focus on the science element. But systems engineering, we are focusing on the systems element or the data element of it. So they are very different. You can look at the different curriculum as well as the different specializations and courses offered under the 2 degree programs. Another question is there any criteria to get into the minor in data engineering? I think that you will need to look at the website for data engineering to understand what is the criteria for this. What are some of the areas of math that are especially used in sustainability? So in fact, many areas of math are used in sustainability. You can see the entire list from my slides previously. So everything from optimization to forecasting to scenario analysis, uncertainty and risk analysis, all these types of quantitative tools, I wouldn't call them math. Quantitative tools are actually being used in the sustainability area to look at various elements of transition planning. So if you were to do the specialization in sustainability analytics, you will be able to learn these skill sets, and then you will be able to apply many of these skill sets within the area of sustainability analytics. So I'm going to summarize some of the remaining questions because we have quite a number of questions. So I know there are a few questions on what is the difference between ISE and the data science. So you will have to look at the curriculum as well as some of the courses and specializations that are being offered to make your decision on which one you would like to enroll in. And it is difficult to for me to say which one is better, but I think that you can look at some of the courses offered, and then look at some of the careers that students have gone into in making a decision on which one you would like to go into. But I would say that ISE graduates don't necessarily only need to be data scientists. There are other jobs available for ISE graduates beyond data science. So that could be one of the differences. And then there are a few questions which are looking at sustainability roles and sustainability internships. So there is a range of roles available. It really depends on what type of role you will be taking up. So for instance, there are roles that are data driven, and then there are roles that are more based on consulting. So we see that ISE has various skill sets ranging from the systems thinking all the way to the data analysis types of roles where you learn techniques, regression, machine learning, optimization, etc. So depending on the role, it will have a different competitiveness for that role. And also It will be good if you have a sustainability-related internships. In fact, ISE offers a variety of sustainability-related internships on the internship portal. So if you were to join, you can explore those roles, or you can also look at looking for your own internships related to sustainability. So the internship you can actually choose from the portal, or you can also initiate your own internships. And companies, of course, if you have an internship in your resume, it will definitely increase your employability. But I'm sure companies are also looking for other skill sets, the ability to analyze data, the ability to understand energy systems, carbon-intensive systems, and transition planning. It really depends on what type of sustainability role you're applying for. Is it a general role? Is it a role in oil and gas, etc.? So learning some of these skill sets will be important, and also understanding which kind of industry you want to go into will be important. So I think Gui Ting gave an very good example of his final year project, being able to take a step into this industry, explore the industry, and then see whether it is suitable, and also to learn the skill sets and understand some of the problems that are faced in this industry. So it's an opportunity, I think, for students to better understand what you want to do and what roles there are available. Okay, let me see if there's any more. Okay, how many internships do you need to graduate? You need to do one industrial attachment in order to graduate, but you can do more than one. So the other one may or may not be credit bearing. Okay. So for the question about how, if you are from Poly, what courses do you usually take? You can take a look at the website. We have two recommended schedules. One is for the Poly intake and one is for the non-Poly intake. So for those who come from Poly, you can look at the schedule and see what kind of courses are required and what are the exemptions. Okay, let me see whether there are. Yeah. Okay, are there any more questions from the floor? All right. If there are no more questions, then thank you so much for coming to today's webinar. I hope that I was able to answer most of the questions and give you a good overview of the Bachelor of Engineering. And I hope to see you in the new academic year. So thank you so much for coming, and if you have any more questions, you can contact me at my email address at gotian@nus.edu.sg. And just to tell you that as you work on sustainability, every action counts, so we can make a difference together. And I hope that everyone will participate actively in helping Singapore to get to net zero. Yeah. Thank you, everyone.